Hello and welcome to this video on interpreting graphs of functions. Um, in this video, I'm going to do one example that I've pulled from an intermediate algebra text that describes a situation, and after the description of a certain scenario, we are asked to draw a graph of that particular scenario. All right. So really this is not, and then we could use that graph to, if we were to show the graph to someone who hadn't read the problem, that person could interpret that graph and figure out what happened in the problem. So I think that's why the heading here is interpret graphs of functions. Alright, so let me begin. So the example I have for you today is this one here. So let's read it carefully. So Clara decides to take a walk. She leaves her house and walks 5 blocks in 5 minutes at a constant speed, right? So that's going to be key there. All right, so that means she's walking at, 4 miles per hour the entire time, or 5 miles an hour the entire time at a constant speed. Her speed is never changing. She never speeds up or slows down during that 5 minutes. So she leaves her house and walks 5 blocks in 5 minutes at a constant speed. She realizes that she left her front door unlocked. So she runs home in 2 minutes. All right. And I'm going to assume, again, being that it is an intermediate algebra text I am pulling this from, that we are still talking about anytime she's walking or running, it's going to be at a constant speed. So she'll run at a certain speed and never speed up or slow down during those 2 minutes. When she's walking at a constant speed. Okay, that makes the, again, just because it's in this intermediate algebra context. It then takes her 1 minute to find her keys and lock the door. She next jogs 8 blocks in 5 minutes. Again, jogging probably, I'm going to assume here at a constant speed. She next jogs 8 blocks in 5 minutes and then runs 3 blocks in 1 minute. After resting for 2 minutes, she walks home in 10 minutes. And so we've been described this scenario of Clara's journey here to and from her home, or away from and then back to her home. And we're asked to draw a graph of Clara's distance from her home in blocks, right? So you notice the units for all the distance was given, blocks. So we don't know exactly how long that is. All right, so just a block, distance between one street and another street. So let's just say in blocks, right, and assume they're all the same length here if we're in the same city the entire time. So draw a graph of Clara's distance from her home in blocks as a function of time, right, in minutes. All right, so I'm going to assign these quantities, a letter or a variable, so I just don't have to keep writing them. So I'm going to have D represent Clara's distance, distance from Clara's home. Okay, and this will be in blocks, the units of blocks. And we're trying to write distance here as a function of time. All right, so I'll have typically a lowercase, script t will represent the time. Right, and all the units for times in this problem were given in minutes. So when you're told this, write distance as a function of time, I've talked about this in other videos. If you want to go back and watch videos introducing, talking about functions, please do, but you don't have to. I'll describe it a little bit here. When I'm asked to write distance as a function of time, what that means is that every time corresponds to exactly one distance, right? So time here is going to be considered the independent variable. And when I go to make a graph, typically, we're used to seeing x and y, right? Where x is the independent variable, and that's usually represented on the horizontal axis. So in our problems here, typically the independent variable is represented, values of the independent variable are represented on the horizontal axis. And I'll label that in my picture on the next page, right, when I make a graph. And then the distance, every time is going to correspond to exactly one distance. Distance will be a function of time. So, time is the independent variable, the input in here. Then the distance would be the output, or the dependent variable. And typically that's, the y value if you're thinking x and y, and that's the values of the dependent variable are typically represented on the vertical axis in a graph. All right. Okay, so keeping all this in mind, let's go to actually doing what they asked. Let's draw a graph. Now I'm doing this on graph paper. You do not have to do it on graph paper. Just make sure that when you're drawing, make sure your axes are nice and straight and perpendicular to one another as best you can. Make a 90-degree angle, and when you mark off the units on your axes, just be consistent. Make sure they're nice, as equally spaced as you can make them. And in the distance, make sure that the distance between each notch on the horizontal axis represents the same amount of units, and the distance between each notch on the vertical axis represents the same amount of units, right? Just to be consistent. All right, so I'm doing this here on graph paper. So I notice I have the bulk of it up here where my horizontal axis, again, number line, vertical axis, number line. The point where they meet is when they both have a value of 0, right, the origin. Notice how I have the bulk of it in the upper right quadrant, where the horizontal axis has positive values and the vertical axis has positive values. The reason I made it this way is because we're talking about distance from Clara's house, right? And having negative distances doesn't make any sense. And also we're talking about time, right? Our two variables here are distance and time, where, and talking about negative distance and talking about negative time really doesn't make any sense in the context of this problem. That's why I have, the bulk of this page here in line with the positive horizontal axis and the positive values on the vertical axis. Okay, now as I mentioned on the previous page, our axes, the horizontal axis typically represents values of the independent variable, which again, if we're writing distance as a function of time, time is the independent variable. So I'm going to call this the t-axis, right, or the time, right, the time axis, and this is time in minutes. I mentioned that on the previous page. And the vertical axis, right, again, it will represent values of the dependent variable. I called that, that's the distance here. So I'm going to call that the d-axis, right? So the vertical axis here represents, I'll write this up and down like this. This is distance. Remember, this is in blocks, right? All the units for distance is given in blocks. Alright, and I'm going to have it, I noticed that, none of the numbers that were mentioned in the problem were very large. I'm seeing 5s and 1s and 2s and maybe, 10's the largest number I'm seeing. So what I'm going to do here is I'm going to have every unit, I'm going to have every square on the horizontal axis represent 1 minute. So there's 1 minute, 2 minutes, 3 minutes, right? Remember it's time in minutes. And I'm going to have every square on the vertical axis also represent 1 block. So there's 1 block away from Clara's house, 2 blocks away from Clara's house, 3 blocks away from Clara's house, and so on. All right. So when I start this graph, we're going to I'll plot some key points as we go through, and then we'll connect the graph at the very end. All right, so at the start of this walk, when she begins, no time has passed, right? So we're at time 0 minutes at the beginning of the walk, and she hasn't gone anywhere. She's at home. So we're going to start this graph here at the origin, right? And perhaps I will even label some of these points, right? So I have the ordered pairs 0 for time, 0 for distance. At the 0 minute mark, she is 0 blocks away from her house. She's at her house. All right, then let's go back and read through the problem one little sentence at a time here. So she decides to take a walk. She leaves her house, walks 5 blocks in 5 minutes, and again always at a constant speed. So she walks 5 blocks in 5 minutes. Alright, so in 5 minutes, so there's 5 minutes later, 1, 2, 3, 4, 5, she has walked 5 blocks, right? So she's 5 blocks away from her house. This is 1, 2, 3, 4, 5 up. So 5 minutes later, she's 5 blocks away from her house. So that's this location here on my graph. Again, I'll label these points. 5 minutes, 5 blocks, right? 5 comma 5. Now the key to how the graph's going to look is they mention that she's walking at a constant speed. So she's not going 4 blocks in the first minute and then slowing down and doing the last block in 4 minutes, or she's not taking her time and doing the first block in 4 minutes and then speeding up real quick and doing that last 4 blocks in 1 minute. She's doing the same number of blocks, it looks like a block a minute, right? If you're doing 5 blocks in 5 minutes. Now when they ever say constant speed, if I'm moving at a constant speed on a graph, that'll be usually represented by a straight segment, right? So no crazy curves, just a straight. I started here at home and I went 5 blocks in 5 minutes, just a nice straight segment, right? So that means she went a block a minute. 1 minute later she was 1 block away. 2 minutes later she was 2 blocks away. 3, 3, 4, 4, 5, 5, right? The same speed the entire time. Right? No faster or slower at any given moment. So yeah, usually a constant speed. If they say somebody's moving at a constant speed, that will be represented on a graph of distance versus time here as a straight segment. Great. Alright. Now she's 5 blocks away from her house. And it's like, oh. Alright, then she realizes that she left her front door unlocked. So she runs home in 2 minutes. So she runs home in 2 minutes. So 2 minutes later, so we're at the 5 minute mark here. She's like, oh, left my keys at home. Left my door unlocked. So in 2 minutes, so 6 minutes, 7 minutes, right? So we're at the 7 minute mark. In those 2 minutes, she runs home. So that means she's back home, meaning she's 0 blocks away from her house. She's at home. Now again, I'll label this point. This is the point 7 minutes. She's back home. So 7 minutes, 0 blocks. And again, I'm going to assume here that we're going every time she's moving at a constant speed. So this will be just simply represented by a straight line graph, a straight segment moving at a constant speed. Great. So here's a graph representing the first 7 minutes of her journey. All right. It then states that it takes her 1 minute to find her keys and lock the door. It takes her 1 minute to find the keys and lock the door. So that means during that 1 minute, she is at home. So she doesn't move away from her house. So from the 7-minute mark to the 8-minute mark, 1 minute, in that minute, she is still at home. So even at the 8-minute mark, she is 0 blocks away from her house. And I'll label this point as well. There's 8, 0. Right, 8 minutes later, she's still at her house, 0 blocks away, and didn't move at all. So during that entire minute, we have all these points. Right, fill this in a little thick here. Every single one of these points in here is part of the graph because during that entire minute, she is at home. She is always, in this minute, 0 blocks away from her home. She is at home. So a nice little straight segment between 7, 0 and 8, 0. All right. Then after that, it says she next jogs 8 blocks in 5 minutes. Again, we're going to assume at a constant speed again. All right. So she next jogs, so she found her keys, locked the door at the 8th minute there, and then in the next 5 minutes, so 9th minute, 10th, 11th, 12th, and 13th, right? Then the next 5 minutes, it takes her, she jogs 8 blocks. So 5 minutes later, at this 13th minute, she is now 8 blocks away from her house. So we're up here to 8 on the vertical axis, distance. So I'm at this point here on the graph. So at the 13th minute, she is, 8 blocks away from her home. So there's the point, 13 minutes, she's 8 blocks away, 13, 8. And again, we're assuming here that she's moving at a constant speed, so she's not running really slow at first and then speeding up, or run really fast at first and then slowing down. Just the same speed the entire time, represented by a nice straight segment between these 2 points. Alright, so that's the jogging 8 blocks in 5 minutes, right? So now 13 minutes after she started, she is 8 blocks away from her house. Alright, and then after the jogging 8 blocks in 5 minutes, then she runs 3 blocks in 1 minute. So I'm at the 13th minute. They're saying she runs 3 blocks in 1 minute. So after the 1 minute later, she's at the 14th minute. She's jogged 3 more blocks. So from the 8 blocks away, now she's 9, 10, 11 blocks away. 3 more blocks in that next minute. So we're at this location on the graph. 14 minutes after the beginning of her journey, she's now 11 blocks away from her house. So there's the point 14, 11. And again, nice straight segment here, right? We're assuming all this is at a constant speed. All right, great. 3 blocks in 1 minute. All right, then after resting for 2 minutes, now let's think about that for a second. So they say she rests for 2 minutes. So we're here right now at the 14th minute. She rests for 2. So the 15th and 16th minute. So for these 2 minutes, she's resting. She's not moving at all. So you see at the 14th minute, she was 11 blocks away from her house, and then she rested. So for the next 2 minutes, she is still 11 blocks away from her house. She has not moved. So we're going to this point here. So at the 16th minute, she's still 11 blocks away from her house. There's the ordered pair 1611. Again, not moving at all. So definitely moving at a constant speed, right? Moving nowhere. Right? During that entire 2 minutes, I got a nice flat segment there. During those 2 minutes, she still has, still 11 blocks away. So all of these points for these 2 minutes, she is 11 blocks away, every single one of these. So 15 minutes, she's 11 blocks away. 15 and a half minutes, she's 11 blocks away. 16 minutes, she's 11 blocks away, right? She hasn't moved this entire 2 minutes. She rested. And then finally, after resting for those 2 minutes, she walks home in 10 minutes. So she walks home. She actually gets back to her house, meaning, she's 0 blocks away from her home. And this takes 10 minutes. So we were at the 16-minute mark, and this takes her 10 minutes. So 17, 18, 19, 20, 21, 22, 23, 24, 25. There's 10 minutes later, 26. So in these 10 minutes, from the 16-minute mark to the 26-minute mark, she walks from, being 11 blocks away, she walks home, makes it all the way back to where she is 0 blocks away from her house. And anytime, so basically anytime I'm on the horizontal axis, this point, these points, this point, that means she's back at home. And again, I'm going to assume, because it wasn't mentioned otherwise, that she is moving at a constant speed, always walking at the same speed. So not walking really fast in the first few minutes and then slowly, or walking really slowly and then really fast, but walking just a straight line, just a nice, walking the same speed the entire time. Again, constant speed is indicated by a nice straight segment on a graph. And there you have it. Right, and I'll label that last point as well, right? So the whole journey, right? The whole journey from start to finish took 26 minutes. Right? Took 26 minutes. Okay, and that's it. And then they asked us to draw a graph, right? Which I have done here. And then we could title the graph, we could say, and then if we gave it to someone, we could title the graph Clara's Journey or something. And perhaps we'd label this a little more, maybe blocks from Clara's house, time in minutes, and then, ask someone to look at this picture, and they could probably give you a pretty accurate description as to how Clara moved during this 26 minutes. If I look at this segment here, this tells me that, she started at home and then went 5 blocks away from her house in the first 5 minutes. Now, I wouldn't be able to tell if she walked or jogged or ran from this, but you could probably make a guess. The fact that she went 5 blocks in 5 minutes here, and she went 3 blocks in 1 minute on this segment. This is steeper, right? A steeper segment would imply that she was moving faster. So I might look at this segment here from the point 13.8 to the point 14.11. She went 3 blocks in 1 minute as opposed to 5 blocks in 5 minutes, which is just 1 block a minute the whole time. I would say she was probably running here and walking or slowly jogging here. But this is what I mean by interpret a graph of a function, right? Just being able to make conclusions based on just a picture. So in the first 5 minutes, she went 5 blocks away from her house. And then I can't tell you exactly why she went back. Just by looking at this picture, I could make something up. I noticed that in the next 2 minutes, she decided to go back home. And it's actually, she went back home a little faster, right? This is steeper than a block a minute, right? This is 5 blocks in 2 minutes. She went 5 blocks in 2 minutes, not 5 blocks in 5 minutes. So this is even steeper. So she probably was going a little faster. So maybe she was walking here and then running here. But for some reason she decided to go back home. Now if I was only looking at this picture and didn't have the word problem to read on, I might say, oh, maybe she realized she left the oven on or something, or she left the door open, or the TV was running, or she got a call to come home for a little bit, whatever. Uh, I don't know from just looking at a picture, but I can make a guess. No matter what I guess, though, she did go back home in those next 2 minutes. And then I see this piece of the graph. It's like, ooh, it's flat. The distance isn't changing, so she is continuing to be home for this next minute. Again, I can't guess why she was home just by looking at a picture. I could probably say, oh, maybe she decided to, walk and then come and then, and she rested for a minute and decided to go back out. Or she got what she was looking for and decided to go back out. I don't know exactly what just from looking at this picture, or if I go back and actually read the problem. Then in this segment, I'm seeing that she left her house, and then in 5 minutes later, she was 8 blocks away from the house. So she was going even faster than before, right? Before she went 5 blocks in 5 minutes. Here she's going 8 blocks in 5 minutes. It's even steeper, so she's going even faster. So maybe she was walking here and then jogging here or running here, or on a bike, maybe slowly, or a scooter or something. I don't know. Again, if I didn't read the problem and just looked at this picture, that's how I could interpret it. And then I'm saying, hey, after that 5 minutes there, from 8 to 13, she decides to speed up. It gets even steeper. So maybe she pedals faster, or walks faster, runs faster, whatever, for the 3 blocks in 8 minutes. And then she got, oop, I'm pooped. She gets tired at the 11 when she's 11 blocks away from home at the 14th minute. And I see maybe she saw a person outside and decided to talk to him for a couple minutes, right? This is for 2 minutes. Maybe she saw a friend of hers, or just decided to rest. She was tired. Again, in many ways you could interpret this, but she is staying in the same place, staying put for 2 minutes. And then I'm noticing, she got sick of talking, or she was done resting, and I notice, she's going back home, back to 0 blocks away from her house. And here she's going, 11 blocks in 10 minutes, which is still even faster than the first 5 blocks in 5. That's a block a minute. This is a little more than a block a minute. Right, 11 blocks in 10 minutes. So she's maybe walking still, but probably walking a little faster than she was in the beginning, because it is a bit steeper. And then 26 minutes later, and it's like, oh, maybe that's her workout for the day. I don't know exactly why she took this journey. I don't know what she was doing. Again, if I was only given the picture, there are many ways I could interpret her movement, but you can still see her movement. You can still pretty accurately say what was going on just by interpreting this function. Alright, this picture of this scenario we read. Okay? So yeah, so there might, you're going to come across problems like this where you'll have to, make a graph of some situation yourself, but and when you're making them, try to make the graph so it's nice and properly labeled, maybe even titled, Clara's journey. Label points when necessary, some key points. Make sure your axes are properly labeled with what variables they represent, what units are involved. Also make sure that the notches, the distance between units, are consistently represented on your axes. Just so someone outside the problem, someone else, if they were to read it, they could understand what was going on, or at least make a nice educated guess as to what was going on based on your picture, even if they didn't read the problem. Alright, so as I like to say at the end of these, try your best, do the best you can to understand material and learn material on your own before you go looking for help. I find that things tend to stick with people better. People tend to remember things for a longer period when they've put in the time and the effort to learn it on their own. So read the material, of course, read the author's examples, Perhaps even work out the solutions to some of the author's examples before you look at how the author did it, and then compare your work with the author's and see if you can learn anything from that, learn from any mistakes. Of course, work on practice problems, exercises, look up answers when they're provided, if they're provided, just to check yourself and keep track of your progress. And don't give up after the first attempt or even the first couple of attempts. Make several approaches at a problem. There might be more than one way to do something. But if after several approaches at a problem it's still not you're still not getting it, you're still not seeing how to work it out, maybe you should go back and read the material again, more slowly, more deliberately. Maybe even a third time, a third read through of the material might help, because you might catch something that second or third time through that you didn't the first time, or something might make more sense the second or third time through that didn't make sense the first time. Especially after you've worked on some problems, maybe reading through it again will shine some light on what you're supposed to be doing. But if after several read-throughs of the material, several approaches at problems, you're still not getting it and still not clicking, then it is not a sign of weakness whatsoever to go out asking for help. That is what other people are there for. So, ask a teacher, a tutor, a friend, someone in the class who you know knows the material well and who is willing to help. Look for supplemental materials online. There is plenty out there, I assure you. Look for videos on the subject, perhaps videos like this one, or other ones out there that are plenty better than this one. I assure you, you can find them. Just do a simple search. Type in the topic you're researching or studying. I'm sure you can find them. But just keep at it. Don't give up. Stay persistent. Keep practicing. And try to have a positive attitude as well. That can make all the difference. I know it's easier said than done. If you've hated math your whole life, or you've never been good at it, or you keep saying that to yourself, because that tends to stay true. If you keep thinking it, it's going to keep being true. So try to have an open mind. Try to go into something thinking I'm gonna learn something here. I'm gonna take something away from this. I'm gonna stick to it. I'm gonna keep positive, and that can make all the difference in the world. So just, stay persistent, keep practicing, stay positive, don't give up, and I know you can get it. And thank you for watching.